Thank you for the introduction, and it's a pleasure to be here. I really enjoy getting together with Clojurists and being able to do this, and I really appreciate the Big Ten approach that Reclojure has done with bringing in all the community groups and everything else. That's fantastic, and it's been so cool to hear about all the different stuff and all the people who are working so hard to make Clojure and the Clojure community a great place to be. So my talk is called The Amazing Clojure, which you might also call the Maze in Clojure. And I had this idea while reading this book earlier this year of doing a talk, which is a cool book. So you should go check it out. So I had this idea, like, what if I could generate mazes with Clojure? What if I could solve mazes with Clojure? What if each cell of a maze represented a set of slides and then the talk order was generated from a maze solution? This is a really cool idea, and it's a really bad idea also. So I did this, and the results were not good. So it is very hard to build a narrative structure when you don't know the order that anything is going to be in. So I didn't end up doing this. So sorry about that, or you're welcome, whichever one is appropriate. And so instead, this is going to be a talk in 3 parts. The first part is going to be about mazes, because I wrote a bunch of maze code and it was fun. And so I heard yesterday on a keynote that you're supposed to do things that are fun. So we're going to do a little fun first, and then we're going to talk about Clojure and why Clojure is awesome, and some of which you've heard today. And we're going to talk a little bit about future Clojure stuff. So I'm going to go back to the beginning. The Amazing Clojure, the Mazes for Programmers book. Do that. This stuff. Part 1, mazes. All right, we're all caught up. So what is a maze? So if you could actually install the 1913 Webster's Dictionary in your dictionary, which I recommend doing, because it has really cool stuff in it that's much more interesting than the dictionaries that are installed by default. So these are some definitions for maze that are in the Webster's Dictionary from 1913, which really gives you a lot of the confusion, perplexity, bewilderment, baffling, a lot of good words there. That was indeed my experience of trying to build a talk that was in the form of a maze. So, but I found a solution, which was to not do that. So there are a bunch of maze algorithms. There are probably, I don't know, 10, 15 different ones that are in the book, maybe more if you take some of the exercises and ideas in there. I'm going to talk about 2 of them. This is a really simple one. I think this might be one, if not the first one that's in the book. So the basic idea is, starting from the top left, that you move right, and then do the top row, then do the second row, third row from left to right. And at each step, you randomly decide to either extend the run that the passage you're carving to the right, or end the run that you're on and carve a random passage down from any cell in the run that you just made. And I have slides here, but that's no fun, right? Let's do some stuff, and let's do some code stuff. That's more fun. So, and I'm using Rebel here. And so I have a representation of a map of a maze, which is just a map, and it's got like an adjacency matrix kind of thing in it, and some other information. But that's not fun, right? We need to actually show this. So I wrote a little viewer for Rebel to show me that maze. So this is just so we can make new mazes, lots of mazes. And all the mazes we're talking about or almost all the mazes we'll talk about today are perfect mazes, which generally you can pick an entry and an exit point anywhere on the maze, and there should be a path there. So you can try to pick that out yourself if you like, but this is just a typical algorithm. And then I wanted to show how we're carving, which I have slides for, but like I said, that's no fun. So here's some code, and I thought it'd be useful if I just went into here and put a little tap in there. That seems like a good idea, right? All right, so I made a new one. Oh, look, there's all these mazes here. How convenient. All right, so I'm gonna browse off of that tap, and then we can walk into that, and we can actually step through all the steps. So you can see that as we move to, so we're going to start in the upper left, and in each cell, so in the first cell, we're going to randomly decide, should we carve down or to the right? So we decided to carve right, right, right. And then we got to the end of a run. So in this step, we carved down instead. And that ended that run. And then so we start over at the next cell, which is this one right here. Oops, lost my, there. So in these two, they both basically carved down. So we didn't, so several times in a row, we just carved down instead of going to the right. And we're just going to keep going. So I'm just rewalking all the code that all the things that happened while I was generating that maze, right? Oops. No. So there we got to the end. So we ended up with a maze, right? So that's a really simple algorithm. There's some other ones like that. You might see that if you look at a few of these in a row, so let me go back to, so if you look at a few of these in a row, I'm going to make a bunch of them. Tell me if you see any similarities here. Look at the bottom row. Because the only choice when you get to the bottom row is going right, you can't carve down. All of these have a bottom row that's open. And often you end up with a right column that's mostly open. So this is not, this can't generate every possible maze, right? It has some biases to it. And there's several algorithms like that that have some kind of bias built into it. And then there are other ones that do not. So this is, there's one called Wilson that makes mazes. So that's cool. Those don't have that property. Or there's one called Hunt and Kill. So these are cool. The one I like the best is actually this one, which is a recursive backtracker algorithm. So this one just tends to make things that are pleasingly curvy, if that makes sense. And this is a very simple algorithm. Actually, go in and look at where I'm at. I can't, the stupid thing's in the way. All right. Let's see if I could find my backtracker in here somewhere. There it is. So same thing here. Oh, I do. I was actually already tapping it. So how convenient. How convenient. I got lots of stuff in the backtracker now. In the tap now. Browse that. Starting to get a lot of data in here, so. All right, so the way recursive backtracking works is, shoot, I need to get to the right place in here. All right, so recursive backtracking, we're just going to carve as far as we can until we run into a dead end. So keep carving, keep carving, keep carving. Oh, we had a dead end, right? So then you just pick a random new place that you've never seen before and start carving a new edit. And we picked a place right in here. There wasn't far to go. So now we're going to find a new place, which was up here. And now we're going to find a new place. And here we're going to get a lot of room to run. And you're going to keep going. And sometimes it takes a while to get through all of this stuff. But in the end, you end up with a cool maze. So that's cool. So these are my backup slides, which we don't care about because everything worked flawlessly. All right. So an interesting thing I ran into as I was doing trying to make a talk out of this was I immediately found when you looked at a maze that that often not very many of them would have, not very many of the cells would be involved in the solutions. So I guess I haven't shown this yet, but it's more fun if you solve these mazes first. So let's do that. So this is just a maze with a solution in it. But you notice that the path length here is 27. There's 64 total squares. So I'm only using like, you know, maybe a third or somewhere in the quarter to a half range in most mazes. So there's a big one, but it seemed like a lot of effort for me to make slides for all those cells and then not use a third of them or a half of them. So that made me disappointed. So what I did instead was there's another kind of maze called a unicursal maze, and that is basically a space filling curve that will, let's see, this is solve uni. Did I do that? Oh, I used the wrong one. I did. So, and this is unicursal. What's happening here? I bet you I know exactly what happened. So I think this threw an exception, which you can't see because you can't see all of my screen. I think this one expects there to be a starting cell, which I defaulted other places. I don't know what I did. That's sad. Oh, I know exactly what I did. So this is the problem with unicursal mazes. So the way you make a unicursal maze is basically the same as recursive backtracking. And then there's there's two ways to make it. One is actually to take do I have? So one is actually to, sorry, I actually missed a slide here. I missed David Bowie. So unicursal mazes are also called labyrinths in some places. So, you know, had to get a picture of David Bowie in here. So there's two ways to make a unicursal maze that I know of. So one is to take any perfect maze that you already have and effectively cut all of the paths that you have in half. And so as an example here is a perfect maze, a 4x4 perfect maze. And so basically I drew a half line between all of the existing things. And you'll see, and you have to add an extra little close. You have to close off the first spot here to make the entry point. And you then always will end up with a unicursal maze that exits right next to the entrance, because we basically have stolen, you know, that same entrance path. This always works. It's fast and it's really boring. And so that's no fun. The other way to do it is with recursive backtracking. And so just like we did recursive backtracking before, you want to keep going until you hit a dead end. But instead of starting at a random point, you then back up and undo your path to the point where you can make a different decision. This is kind of what's called, oh my God, complexity. It's not actually exponentially bad. It's actually much worse than that. So it's, you know, some sort of factorial bad if you're super unlucky. There are tricks. So you can do things like memorize dead paths so that if you return to them, you don't revisit them. You can think about how to detect the case where you hit a wall and you've got live cells on either side of you. You are not going to be able to revisit both of them. So you found a dead end. You don't have to go visit the whole inner part and stuff like that. But it's still bad. So the reason things aren't working is because my computer is thrashing itself to death trying to make an 8x8 unicursal maze right now, which is bad. 8x8s can take a very long time to make. so that was the problem there, was that I did too much. So I am going to give up and rebuild my environment here. This happens, even to me. Oops.
That's the risk.
So if anybody has, yeah. So if anybody else there has imposter syndrome, I managed to break my environment yesterday in a way that nothing that I had done for the last several weeks worked. And it took me a good half hour before I realized what it was.
What was it?
I'm not going to go into it because I haven't released the code yet. So, all right. Let's be a little less ambitious. Great. And I do think this thing takes a starting cell. Let's see if that works. I think I'm connected. Oh, I'm not connected. Sorry, I'm running actually a fairly large pile of unreleased various bits of Rebel. So it's not all entirely baked yet. It's still not connecting for me. I don't know. It doesn't matter. We're going to go on. So I have slides. This is why we prepare. So this is an example of a slide made with unicursal recursive backtracking. This is an 8x8. My computer just accidentally happened to be very lucky and made this in 11 milliseconds. But most of them took more like 20 minutes when I was making them. So this is an example of one that does not have an entry and exit that both happen right next to each other. It's got, where's the exit? Yeah, here. So it's upper left and upper right are the entry and exit for it. So anyways, that's cool. So how do we solve mazes? Dijkstra's algorithm. You basically flood the maze, record the distance, and then from the end, choose a path with decreasing distance. And then you have basically a backwards path at that point. So you just reverse it. You can also do a depth first search with backtracking, and that's basically how the unicursal solver, it just follows it. This is a example of what the distances look like. So this is a pretty big maze, and it's flooded from the upper left, basically finding distances. So the color here is basically distance from 0, 0. And then so wherever you want to find a path from, you can pick the bottom right and just follow a decreasing gradient of color until you get back to the beginning. All right, let me move this out of the way. All right, so that was some maze stuff. That was fun. I assume you probably are asking, that looks fun. Could I have that code? And the answer is yes, but not now because it's a big mess. But what would be really cool with it would be to have something in the clerk garden that showed off some maze stuff. So maybe I'll do that, but probably I won't have time, and I'll just release maze code. Somebody else can do that. So Clojure. Let's talk about some Clojure stuff. Recently, a bunch of us got together and celebrated Clojure's 15th anniversary. We also had a video thing that went out from Nubank. Unfortunately, Focus was not able to be there on this weekend, so he's not pictured. And also, I want to say happy birthday to Focus. Yesterday was his birthday, so I will get that in there. And I want to take this opportunity to say thank you to Rich Hickey. So there's a bunch of cool people in the Clojure community. There's a lot of amazing ideas. A lot of the things that I think are important about Clojure come from obviously from Rich's brain. I didn't end up working with Rich by accident. I looked around and tried to find people that who I thought were doing important work. And that's how, one of the ways that I got to Clojure. And so I want to thank him for making Clojure, and the way that he thinks about problems are really important. And I say this all with a little bit of trepidation, because there is a lot of pushback in places about the sort of hero worship of Rich or whatever. And I think those are fair criticisms. And Clojure is not just Rich, obviously. There is a huge community, which we have seen all day, yesterday and today. And so there are many, many people that make Clojure great. But I personally think Rich is one of the most important computer scientists of the last 20 years, maybe ever. And it's really all about the way that he approaches problems and problem solving, and making that the focus of everything. So this is my mini appreciation for Rich. So thanks, Rich. And when he started Clojure, this is a picture that he's used in some other talks and things like that. The important thing here was trying to think about what are the problems that programmers face when we build systems. And the two biggest ones were domain complexity, which is something that is built into the domain. So that's not something that we inherently can fix, right? And the second one is misconception, which is just working on the wrong thing, or solving the wrong problem, solving the problem wrong. There's a lot of different variants of this. Again, this is not a programming problem. This is a human problem. But it is something to keep in mind as you think hard about, what am I doing every day? And then there's a big slew of problems that are really important and are the domain of programming languages. And so just looking at a few of these, like place-oriented programming, the sort of centrality of mutable places and mutable databases. Both of those are sort of what he calls place-oriented programming. And there are so many problems that come out of that. And so his search really was for how do we work in a way that is not that. And there was already a lot of work on immutable data structures and things like that, Okazaki and all those kinds of things. And it wasn't until he found the hash array map tree work of Bagwell that this really became a thing that he could address in the programming language. And I would argue that he has, extended that to a large degree into Datomic, which takes the same sort of approach to data in the database. Weak support for information. This is really, the idea here is information is sparse. It has partial information. It has increasing information over time. As we work on things, we tend to add attributes to it. Open maps, open polymorphism, all those kinds of things. It all comes out of this. And I'm not going to talk about all these. Weak support for names is another really important one. But a lot of these are very visible in design of Clojure. They're still visible today. There's still things we talk about every day on the Clojure team are these exact things. So that's, if anybody, has enjoyed using Clojure to work on their systems, the focus on these problems is why. That is the big thing. Clojure works. So I want to go through just some reasons that I love Clojure. So Clojure works, and I think it is clear from the State of Clojure survey. This is from 2 different questions on there, that people are using Clojure more and more for work. They're using it more and more in big organizations. There are more and more downloads. We just recently crossed 2 million downloads a month for the main Clojure artifact. You'll see the unique IPs are a more complicated picture. There's a big reason for that, which is that in April, we released Clojure 1.11, and in June, we released Clojure 1.12 Alpha 1. So those 2 things make people download new stuff. But there's 250,000 IPs downloading Clojure from somewhere every month. So there's a lot of people out there using Clojure. There are now a bunch of Clojure unicorns. Nubank, I'm somewhat familiar with. But other ones that have happened over the last year or two, Imperity, Reify Health, AppsFlyer, TaxBit, I'm sure there are others that I don't even know that are on this list. And Nubank now has more than 1,200 Clojure developers, more than 1,000 microservices. I don't even know how much lines of code, millions of lines of code of Clojure code. So they're a huge, a huge user of both Clojure and Datomic. But also I know these other companies are as well. And there's lots of other small companies. There's this post that Ed Weibel wrote when Cognitect joined Nubank. And I think I revisit it periodically because I think it was really important. I think it really highlighted a lot of stuff that Nubank found useful because they really made a very considered choice about which language to use based on managing complexity. So this is a quote from, with a few minor edits from that post, which is down in the footer. But they knew they wanted to build something with scale. They knew that the biggest threat to scale was complexity, and they wanted to constrain and mitigate categories of complexity. And so they were, reading out of the tar pit, looking at databases that led them to Datomic, which led them to Clojure. So this is I think a fascinating way that a company the size of Nubank, got started with it. So it's very interesting. And I don't think it's that much different from some of the things that Bradford was saying in his talk. We have, Clojure is squarely focused at how do we reduce the complexity of writing and evolving our code over time. And that is our damper in many cases. That's the thing that stops us from moving forward. Clojure makes us happy. In the Stack Overflow survey, Clojure is one of the most loved languages. It was also this study that people did of, I think it was of words in different GitHub repos, or words or comments and issues. I'm not really sure. I don't remember now exactly what the details were, but you'll see Clojure here had the most uses of, awesome, cool, fun, happy, helpful, and interesting in GitHub repos and issues and things like that. So we like stuff that's cool, and it's a happy community in most ways. Clojure pays well. Clojure has topped this survey, I think, every year that we have been included in it. There was at least 1 or 2 years where we were not. So thank you to everybody who keeps filling it out. It is really important for us to show up and be visible in surveys like this. And so I know it's a pain to go fill out surveys, and sometimes they're long and all that, but it really does help in making us visible. Clojure is stable. So Rich has talked about this at length. Breaking changes are breaking, so don't do that. Instead, do things like accretion, which is adding new things, relaxation, which is being more tolerant in what you accept, or make a new name instead of breaking a thing that you have. This has become a cultural value, both in the language and in the libraries, and it is to all of our benefits. So keep doing it. It's awesome. There are some language features that help with this. Things like open maps, open polymorphism, avoiding concretions. All those are things that help with making Clojure stable. Some examples that people talk about a lot. Rich wrote this demo of ants to sort of demo some of the concurrency features of Clojure, which was, I don't know, the code dates till 2009 or 10 or something like that. You can find it out there in a gist. And it still runs today. And the exact same code runs today in current Clojure, just like it did in Clojure pre 1.0, wherever that was. Stu's also famously mentioned that the code for programming Clojure, which was the first Clojure book, continues to run with every new release, and he hasn't modified it too much. I think that's actually slightly wrong. I think there were some examples that actually did break with the 1.3 numerics changes, but in general, that is largely true still. You may have seen this graph floating around. It's been posted on Twitter and things like that. This is from the History of Clojure paper. I did the work to make this graph, which involved a pile of Python and Go stuff. Ironically, I went back and tried to give that to somebody not too long ago, and everything about the Python and Go environments that I had bit rotted so bad that I could not get any of it to run anymore. It was all completely broken. So there's a little bit of irony for you. Just for comparison, I wanted to include a few other ones I think are interesting. So like this is Git. I think you would not be surprised by this. Git is a very stable code base. Linux, also a very stable, very well-managed code base. This is Scala. You might notice it looks a little different. We call this the slumping cake graph. And then this is Rails, which you might also suspect would look kind of similar. So Clojure is flexible. You can take Clojure and you can deploy it on the JVM or to JavaScript or to the CLR, which actually just this week, the Clojure CLR 1.12.0 Alpha 1 compatibility was announced. So the Clojure CLR still exists. I don't know that almost anyone actually uses it, but it still exists. And David Miller continues to bash away at it. Babashka's brought this into the world of scripting, and their work with Graal has been really amazing, and I think has really pushed that team in interesting and useful ways. And so I'm really glad that all of that stuff exists. We've seen Clojure Flutter come out this year with from Christophe and Baptiste. And so again, that's awesome. And I would also include, not as a host, but as sort of a access point, the CLJ Python stuff, which is totally awesome to get access to the Python environment sort of as an escape hatch. The syntax, James Gosling talked about this yesterday, is kind of interesting, is it separates syntax and semantics, and that has lots of pros, things like the homoiconicity and macros and all that kind of stuff, but it has the downside of that you're never exactly sure what you're seeing, what it means. And so with Lisp especially, you can build these towers of abstraction that are that can be hard for people to come into and understand. So you can build a world that's all your own, and the problem is that it's all your own, and so it's hard to understand. And I think Clojure is interesting in that we did not sign up for all of that flexibility. So things like reader macros, custom reader macros, are a thing that definitely fosters this in the common Lisp world, but doesn't exist in the Clojure world. So that's an interesting case where we've not taking on all of that flexibility. There are tons of tools, and I want to mention, like, we've seen all through this conference, if you've watched any part of it, you have seen tons of tools, and they're awesome. And you've seen tools talking to each other in environments, tools embedded in environments, and environments embedded in tools, and all this stuff. And the cool thing to think about is what makes all that work. And the answer is Eden. Like, everybody meets at Eden. Like, you can just pass these literal data structures around and know that, like, whatever tool you give it to, like if it's a Clojure aware thing, like it's talking Eden, right? So I can give it maps and vectors and probably even tagged literals and things like that and have it work. So that is the secret sauce in the middle of all this stuff. And so keep building cool things on top of that. It's an awesome substrate for that. The Clojure community is lovely. You've seen 2 days of that here at this conference. So thank you to all of those people who are doing all this work. Many of them are on this call. Many of them are not on the call. There's tons of people doing stuff. It's amazing. When I do the DREF every week, it is just shocking to me every week that there's, a dozen videos, a dozen blog posts, there's dozens of libraries that are being updated every single week, literally all of the time. So there is no break from it. It is a thriving community. And anybody who thinks Clojure is dead is just completely not trying to find it or trying not to find it, because it is throbbing and alive, I would say. So that's silly. I sometimes I think maybe I should just write a bot that goes out on Hacker News every 6 weeks or so and suggests that some other language is dead, just so we'll throw some more FUD in the water. Don't do that. I'm just kidding. It says sponsorship. I think Clojure is maybe not unique. There are definitely other language environments that have different levels of open source sponsorship. many of those are driven by big companies that have foundations and things like that. But Clojure really does have an amazing amount of funding for open source work. And I think that is pretty great. I don't think the sort of grassroots nature of it is matched by many other communities that I can think of. Clojure's together, you know, it had some time yesterday, but just to resurface that, they are doing a ton of different kinds of funding. They have there are dozens of companies and hundreds of developers that are supporting it. That's awesome. If you're not supporting it, even, you know, to a very small amount, and you have the ability to do so, I would encourage you to do so. Or if your company is not currently supporting it, I would encourage you to encourage them to do that. It's good for all of us. We have an open source, this sort of culture of grassroots support of open source developers as well. Nubank is supporting about 40 developers on a monthly basis, which we don't really talk about enough. So I'm going to write a post about that soon, but we are supporting a lot of people. I know that there are lots, but when I go look at those, there are, you know, often 5, 10, 20 other people supporting those people and projects as well. So it's certainly not just Nubank. There are a lot of people helping each other to make great stuff. So the future. I should have brought my shades to wear those for that. So I wanted to take a few slides, just think about obstacles to spread. And some of these James talked about a little bit yesterday, but language choices are entrenched. You know, it's a big thing to choose a language, and it's very difficult for a company to change to a new language or to have that, you know, decision point where they even really consider another language. And it's very difficult to get into schools and boot camps. There's a feedback cycle here that, you know, schools want to teach languages that people use, and people want to use languages that are taught. So it's very difficult to break into that cycle. Once you do, you get a virtuous cycle there. And I think Python definitely, you know, achieved that. They're probably the poster child of that, that managed to break into that cycle enough to feed sort of a flywheel of continued people who know the language. But it's difficult to break into that. We need to be doing what we can to, the Clojure community does a great job talking to each other. Things like this event and other events, I think we are pretty well connected in the community to each other. I think we are not great at sort of seeking out external communities to talk to. Rich certainly did a lot of this in the early days, going to talk to, you know, Python, Ruby communities, or InfoQ, or, you know, Strangeloop, or things like that. And we need to keep doing that. That's the only way that we're gonna. If you want to grow the bubble, you got to go talk to people outside the bubble. So as you think about, if you want to help with that, submitting talks at conferences is a fantastic way to go talk to other people that that haven't seen Clojure. Familiarity is a big thing. The thing that Rich would call easiness. It's things that are close at hand, right? Clojure is not close at hand for a lot of people who have been through various, you know, computer science or boot camp or learning paths. So the prefix style is difficult for the reasons James talked about yesterday. The parens tend to be a blocker for some people, even if it's silly, it is. Functional programming and immutable data, if you go look at I didn't put it in here, but the Clojure survey for like, what are your obstacles to learning Clojure in particular, you'll find that functional programming and immutable data are at the top. It is a different paradigm. It's a different way of thinking about things, and thinking in recursion also is another thing that's difficult. Getting out of the loop mindset and into the working at the collection level, transforming one collection into another collection, or thinking about recursive algorithms. Those are things that those are very natural ways to structure programs in Clojure, and they're very unnatural for for a lot of other languages. So especially the ones that are taught. So so there is definitely a learning curve there, and I think a lot of that is unlearning, so there's a lot of unlearning that has to happen. People who pick up Clojure as their first language, which is not really that common, but people who do, I think, find it to be not that hard. So I've heard that from a number of people who went that path, but because they have a little less unlearning to do. So some ways to turn this into a positive. Stu did a talk a few years ago about alien technology. And I think I think talking about that, or talking about it as a superpower, talking about it as a secret leverage, things like Paul Graham's essays about Lisp and how that was their secret weapon in, being productive against other, similar competitors using other languages. Like that, the idea here is there is a more productive way to work, and it's not a silver bullet. Like, you're still writing code, you're still fighting the same problems that you fight any other time. So it's not a 10x kind of a thing, but it can definitely be transformative to make this leap and think in a different way. And so finding the right way to talk about that is alluring and brings people in and encourages them is the trick. So we need to keep doing that. I think that's a cool way to talk about it. Jobs. This has been for any small tech, anything that's not super widely spread. The jobs are not evenly distributed among the people, either by geography or skill level. So the things that are, there are just hotspot areas where companies that work with Clojure are, and they typically want more senior level people. That's just the nature of this problem. So the only way to really solve that problem is to have more companies and more developers. So one way to do that is to hire non-Clojure developers and train or mentor them. So I mentioned before that Nubank has 1,200 plus Clojure developers. We didn't go out and hire 1,200 Clojure developers, right? That's just, there weren't 1,200 Clojure developers to go hire. So there were, we hired people who were smart and wanted to do cool stuff, and we taught them Clojure. So you can do that too. Things that are not obstacles, in my opinion, and you're free to fight with me about this, but there are so many learning materials out there for Clojure. People are continually making them. There are really good old ones. On the Clojure team, people often ask us on the Clojure team, why don't you write more learning material? Like, Stu and I wrote Programming Clojure. I co-wrote Clojure Applied. Focus co-wrote Joy of Clojure. Like, we collectively have written three, I think, pretty good books that if you read all those, and you'd know a lot at that point. And this is just scratching the surface. There are tons of other great books out there. There are tons of great online resources out there. Same thing with tools and editors. It used to be a problem to get a good tool. It's not a problem. There are plenty of good tools out there. And I'm not saying they're all perfect. I'm not saying they don't all need more things. Of course they do. That's always the case. The biggest problem for me is it's hard to find the right one, the one that's right for you. So they're not all good for people from a Java background or a Python background or a data science background or whatever. So I think there is a lot we can do to sort of set up starting points and paths, particularly for people coming from different contexts. So that is a place where I think we could do some really good work. And I think it's also, so those are some obstacles, but why is Clojure compelling? It focuses on solving real problems. You get fast feedback, interactive development. You can move fast. It's the thing that Bradford talked about. It's stable, so you don't waste time churning your environment and fixing stuff that's needlessly broken, which is what happens to me every time I use any other language, pretty much. It is flexible. You can respond to requirements, all those things about open systems and evolution over time. It's designed to be flexible. You can do a ton of stuff. The community is great. You can get help so many places now. And the people are awesome. You can have fun doing it. It pays well. It is low friction these days. You can get started really, really quickly, I think. I don't think we do as good a job as we can explaining that to people. So I'll take that one. But yes, I think it's not that hard to get started these days. And you can deploy and reach everywhere. Like, the amount of ecosystem that you can reach is really, like, all of the major ecosystems today, pretty much. So it's pretty awesome. Some key opportunity areas. So it is ridiculous that Clojure is not the favored language for data science. It's a data language. It's we are just sitting smack dab in every place where we should be for this. And so my supreme thanks go out to the Clojure group and all the people who are working on all those libraries. And this is not my area of expertise. I don't know this stuff, but the work is getting done, and I super support all of that. Rich supports all of it. Rich has said multiple times to me this year, Clojure should be the best language for data science. The end. That and I agree. So the more we can do on that, I think that's a place where data science is not going away. It's going to keep evolving. We need to get our foot in the door there and make sure that Python is not the only option on the table, because for me, Clojure lets you get started quickly and make stuff, which is true of Python as well. But I would much rather take the thing that I made in Clojure and make that a production worthy thing. Like, the path to that is way shorter than doing it through Python. In my opinion. So you're going to end up with a much better piece of software at the end in that path, my opinion. And interactive development. Clojure has always had this sort of rapid feedback cycle due to the REPL. The tools that people are putting together today, things like, Data Rabbit and the Clerk stuff, and there's so many people building amazing tools with Clojure. It's not accidental. It's Clojure's designed for this thing. This is where we have always shined, and we should continue to push it as a key thing for Clojure and a key selling point for Clojure. It lets you work interactively with your program, as a living thing, and it is the best part of Lisp and Smalltalk and all of that tradition. And so we are going to keep working on that. So core team priorities. This is not coming from Rich. This is not a roadmap. This is me just sort of reflecting over the things that we have worked on in the last year, a lot of which is not out yet. But things around interactive development, we continue to think that's important. We're continuing to do work with data-defined nav, with PREPL. Rebel is sort of a great tool for doing that stuff. There are others now, like Portal and the other one, my mind is losing me, but someone's out there screaming, and I'm sure. Reveal, thank you. Sorry, too many things in my head. So all of these take advantage of data-defined nav. We have identified some issues around being able to connect Rebel remotely. I don't know if anybody caught that earlier, but I was actually connecting Rebel remotely, not in proc, to Calva when I was doing the maze work. So we have a working version of that. It has some really interesting reusable tech underneath it, which we're going to release. And that should be useful to lots of other people too, not just to Rebel. I've been doing a lot of work on ad-libs recently, so it's coming. We're going to get it integrated into Clojure itself in some way. We're trying to work out the best ways to do that. And some of that also hooks into Clojure CLI a little bit. So we will always continue working on improving interop with JVM host, both to get access to new functionality, things like Loom is a really interesting, and a lot of the value-based stuff that's coming out in the newest JVMs is really interesting. And both to get us access to those new features where they make sense for us, and also for performance. So that work is never going to stop. It's just going to be a continuing, ongoing thing. We've done some interop work this year, which is we have not quite gotten it to the release point, but working on it for 112 timeframe. We'll continue working on tooling. Done a lot this year. Continue pushing that up the hill. And I think working on the new Clojure developer experience, that's a lot of really website and tooling and a lot of different stuff. It's just like I said, it's just connecting the dots that already exist in a lot of places, and thinking about that more. And then I'll include spec. We're not sort of actively working on it the second, but we have been talking about it lately, and hopefully that will get some cycles in the new year, which I'm sure lots of people are happy to know. Would like to get the spec 2 work at least to a point where it's released, even if it's maybe not, the endpoint. We would like to at least get that to a point where it's out there. So I'm going to leave you with this. Move fast and break stuff, but we don't break things, right? So we're not going to do that. We're going to move fast. We're going to make stuff. So I'm making that and I'm sure Bradford would sign up for this. Let's keep moving fast and making stuff. And I want to give a big thanks to the Clojure team. They've done a great job, and I really appreciate everything they did putting this together. And if you're interested in more Clojure stuff, Clojure Conj is coming April 27th to 28th. It will be in person in Durham. It will also be streamed online. So you should be able to get access to that from anywhere, and we would love to see some of you there. And Jordan mentioned Strange Loop. The last Strange Loop will be September 21st and 22nd next year in St. Louis. So that's all I have.